It's counting down, Ben. We're starting.
I don't see a countdown. I see it counting up.
Oh, damn it. That means it started. We're already on, Ben. No!
It underflowed.
We've messed up the beginning already. How are you, Ben?
Doing pretty good. How are you, John?
You know, I am so excited because having gone through now the release notes, I have so many open tabs about things I want to talk about. And that makes me happy.
There's going to be a lot about build system stuff this time. A lot of cargo
Which is,
changes.
my favorite thing at the moment.
Is it really?
I've discovered this about myself, that I jump from one favorite thing to another every couple of years. And right now, build systems are...
Really, you could be using any language,
Yeah.
but as long as you're using cargo, it's fine.
I wonder if we could make cargo build other languages. Maybe we should make cargo the new C++ build tool.
It could be the new make.
Oh, yes. That I think we've got a thing here. What will we call it?
Cake?
We could call it cake.
I'm sure there's got to be a thing already called cake, right?
That's fantastic.
But now that once you have a good name, you got to do it. So,
all right. How about we eat a slice of Rust 160? See what I did there?
I'm sure it's someone's birthday today. If it's your birthday out there, congratulations. This cake's for you. Do you really only have like the two things in your soundboard?
Yep. I mean, why would I ever need anything else?
You have the comedy drum roll, and you have the
That's all I need. Those are the only two sounds. It's great. All right. So the headline feature of 160 is source-based code coverage. Now, this is a thing that's actually been, supported in LLVM, which is the code generation tool that Rust uses under the hood for a long time, and it's been available on Nightly for a long time too.
Oh, wait. What's code coverage, John?
So code coverage is the ability to learn which parts of your code were executed and which parts were not. So this usually comes up in the context of test coverage. So the idea being you want to run your test suite and then you want to see that your tests actually exercised your code well. The most common version of code coverage is line coverage. So it'll show, did this line of code in your program get executed or not? But you also have more advanced things like function execution coverage, branch coverage, and branch coverage is often considered, one of the best ones. The very best of these being path coverage. So the difference between these is for branch coverage, it shows you at each branch point of your program, it sort of knows whether it went down one branch and it knows whether it went down the other branch. And you want to make sure that you cover every branch of every branching statement in your program, as opposed to you ran most lines or every line. The difference here, imagine, for example, imagine you had a single line that had a, if foo, then the value is 1, otherwise the value is 2. Then now you have a branch, but you might have executed that line in your test, but you might only have executed it once, so you only either set the value to 1 or to 2. As a branch coverage, it gives you, better coverage here. Path coverage being the extreme version, where it shows you, have you exercised every possible path, so sequence of branch choices throughout your program, which is much harder to achieve, right? Because as you can imagine, the number of paths in your program is exponential, as opposed to branches, which is just for each branch, did you take or did you not take the branch? So the way that you have traditionally had to do this before this feature landed was you run your program and then you run it in the context of a thing that like looks at the execution of your program at runtime and sort of figures out which parts of your code ended up executing. So you could imagine this happening through things like, checking the instruction pointer at every step in your program, or something more sophisticated that uses, special CPU instructions for monitoring the execution of a program, and just really looks at which assembly code was executed and then ties it back to your source code using debug info, for example. That's the way things have often been done using, kcov or cargo tarpaulin, if you've been using that. What's nice here with this thing that has just landed and through LVM's support for this is that it's instrumented coverage. So the idea being that Rust C tells LVM to include special instructions in the compiled assembly code to sort of record that something was executed. So this means that whenever LVM injects a branch, for example, it can inject an assembly instruction at each side of the branch that reports into whatever the reporting infrastructure is. This branch was taken or this branch was not taken. So you don't need anything fancy at runtime to like look and try to figure out what code actually executed. You can just have the code report what it did. It does slow down execution a little bit, but so does runtime introspection, and it makes your binary a little longer, a little larger. But in general, you would only use this for when you want to measure coverage. You wouldn't use this for your production ready binary or anything. Um, and this has been available on Nightly for a while, and what's happened now is it has stabilized. So the Rust C flag -C instrument coverage is now available on stable. And so if you build your code using this, so you set Rust flags equals -C instrument coverage, and you're on cargo build, the resulting binaries will now have this instrumentation. And that means that when you run them, they're actually going to generate these files that are called profraw files. And those files contain the output of those injected assembly instructions saying which source code lines or which branches were actually taken. And then you can use tools to analyze those output files. There are some from LVM itself that ship with the LVM tools preview component that's available on Nightly. And then there are also separate tools, like Mozilla has a tool called grcov that knows how to parse these. There are a bunch of different tools that does this. And you can use those tools either to generate, a command line output for which lines were covered, which branches were covered. You could use it to generate HTML like coverage reports. You can generate lcov files, which are sort of used for all of these various services out there, like coveralls or codecov.io, that where you can upload these files and then they present this nice HTML interface and graphs over time and stuff. But so ultimately, these end up being compatible with the same kind of output you could get from the old kind of coverage, but it ends up being much more accurate than what you would generally get from runtime introspection.
Yeah, I want to emphasize that what was stabilized here is kind of raw in terms of like user interface. It's really just a compiler flag to Rust, not even a cargo flag or a cargo command. It's really kind of like asking you to use this Rust flags environment variable, which is not a thing people usually use. So there are some tools. There's one called cargo-llvm-cov, which is a nice kind of like packaged up way to pass this flag to all of your various Rusty invocations in a convenient way, which you can use. And then obviously you need to have all these tools.
Yeah, this is very much stabilizing the mechanism rather than stabilizing the tooling.
Yeah.
But it is a very nice improvement to the ability to do this kind of coverage testing.
Yeah, I mean, I'm using it at my job. I believe John's using it at his job. So
Yep, it's wonderful. In the tooling space, we also got a nice improvement to Cargo, or a feature to Cargo that has also existed on Nightly for a long time under the -Z timings flag, which is now just Cargo -timings. This flag makes Cargo run, whenever you run a build, for example, the -timings flag makes Cargo output a HTML page that is a report of the compile time and where that compile time went. So, for example, let's say you were building Cargo itself and you wanted to see, why does Cargo take as long as it does to compile? If you ran Cargo build --release --timings, it outputs this long sort of flowchart diagram of, okay, first we compiled libc, then we compiled autoconfig, and you can scroll down and see a timeline of what was being compiled where, what was the CPU usage at all times. And in general, you can use this to recognize whether there's, for example, one dependency that makes up a majority of your compile time, and maybe you can cut that dependency or optimize the compilation of it. And that this gives you a good insight into where is your compile time going. It's worth noting here that they only stabilized the flag and I think the location of the output, but they did not stabilize the format of the output. So, that HTML page is almost certainly going to change and improve over time. There might be other things that it sort of gains the ability to do, like output JSON reports and such. But for now, the thing that's standardized is just outputting a human readable report of where that time went.
And I believe that in the release notes that there is an example of such an HTML file, which we can link to from in the down in the podcast release notes.
Yeah, we'll do that. This next one I think is something you have some passion for, which is this new syntax for cargo features. Do you want to talk about what's going on here?
I don't know about passion. I think it's an interesting kind of thing here. So let's talk about it first. So whenever you have a crate, say you have various dependencies, you can make them optional. And so I'm not sure if you recall the timeline of cargo, John, but so I'm not sure if like features came well after optional dependencies, or if like there were
I think
if
they
they came at the
came at the
same
same
time.
time.
Well, the idea is that if you make a dependency optional, it means that you then, while compiling the program, you can detect whether or not that feature is enabled. So you can kind of like enable or disable features while you're compiling, and then the code itself, the crates, can say, "Hey, like I can see that this is enabled. Let me like enable these APIs or change around this sort of thing for conditional compilation." And so I think, at least for the crates that I use or create these days, you can also do a more advanced thing, which is you can name a set of crates and then kind of enable them all at once with a single feature flag. So if you have, like, say, a few dependencies that all work together to do a single, like, logical thing in your crate, and you want end users of your crate to just specify like a single thing, and not have to worry about like forgetting one, or like changing things in the future transparently, force compatibility, that kind of thing. You can just package them all up, and then you can say, hey, like here's this feature name. Let's call it foo, and it gives you bar and cooks and baz and like these three crates.
Yeah, a concrete example here might be, if you think about the Tokyo crate, for example, they have a net feature that enables, networking stuff. And that has to bring in some crates. But it also depends on a feature called IO, which enables the IO features of Tokyo.
Right. You can build other features too from with them, and so kind of like you can create like these very like rich like feature dependencies. But at the end of the day, all of these crates that you have that are used as part of your features still need to be optional, and they still introduce an individual name into your features here. So if you are a create author, this can be kind of like annoying, because it means that technically, if you like look at like valid flags that someone can pass for the feature flags while compiling your crate, there are every single crate that is optional of yours, every single dependency of yours that's optional in there, is now one of the optional features, one of the features that they can turn on. That might make no sense depending on what you're trying to do. Like, it is much easier to kind of like tackle the complexity of like different features, because it is actually kind of hard. Like, conditional compilation is always kind of difficult to like test a matrix of and make sure that like, everything's still working. And so you want to try and minimize the number of actual like feature configurations that you as a create author expose. Just make it easy, make your life easier.
Yeah, to give something concrete here, right? Like imagine you're, and this is sort of the example from the blog post too, is imagine you have a dependency on Rayon that's optional, and you don't want people to depend on your crate and set the Rayon flag in order to enable Rayon. You would rather, have a feature flag called, say, parallel that enables Rayon and maybe some other things as well. But the way things were in cargo, if you had the optional dependency called Rayon, your crate would also implicitly have a feature called Rayon, and you had no way to turn that off.
Right. So there are two new features here. One is they're called namespaced dependencies and weak dependencies. And what I'm referring to first here is the namespaced ones, where this is the idea of giving you the ability to have a bunch of optional crates, but only have a few features that like enable the optional crates as needed, without exposing to the end user these kind of like as far as your crate's concerned, incoherent feature flags of enabling like a single optional crate, where in fact like you expect them to only enable a single feature at a time. So this is done by adding the like putting whenever you define a feature, if you put DEP colon before the name of a crate as part of the feature, it will disable uh, the optional dependency as a feature, right? And so like we can argue that maybe it was in retrospect the wrong default. to make it so that a optional crate becomes a feature. Maybe it'd be easier and maybe more elegant if you had to actually opt into it. In this case, maybe a bit more annoying for like small crates, that kind of thing. But any case, if you are a crate author and you care about like the surface area of your API as far as users consuming your crate is concerned, I'd probably recommend just like using this everywhere for all of your crates that you declare as part of your features.
Yeah, one thing I hope comes of this is that more crates have a feature that's just called Certi that enables Certi, as opposed to having a feature called like Certi underscore or Certi1, so that they don't conflict with the implicit feature declared by the optional dependency on Certi.
That's true. This should also let you name a feature the same as a dependency and
Right,
have no
exactly.
problems too. And the other feature landing again, the word feature is overloaded. I don't like that we called it cargo features. The feature of cargo called cargo features uh, is weak dependencies, where the idea is that you enable the feature of a dependent crate of yours only if the crate itself has been enabled in a separate feature by the user.
Yeah, so the thinking here is, let's say that I want to have a feature that enables networking in my serialization crate or something. And that means that I have to enable the networking feature of Tokyo. But Tokyo is an optional dependency of my crate. And I want to enable the net feature of Tokyo, but only if Tokyo itself is actually brought in. So imagine that my crate has two features, one called like Tokyo compatibility and one called networking. I only want the Tokyo dependency to be brought in if you enable Tokyo and networking. If you just enable just networking, then even though that names a feature of Tokyo, I don't want that to also enable the Tokyo dependency that is optional.
Right. So the bottom line is, if you are a library author and you want to potentially improve compile times by decreasing the number of crates that users need to compile, you might benefit from looking at these features, which we'll link from the show notes here, and seeing whether or not you can eliminate some dependencies via this weak dependencies feature.
Switching gears from tooling a little bit and sort of cargo specifically, we now have. I think this has become a kind of running thing, just like LVM no alias, which is incremental compilation. So incremental compilation has now been re-enabled for 160. It was disabled, I think, in 158. Is that right?
It was a
And it
while
was
ago.
and
Yeah.
it was enabled in the middle and then was disabled and then it was re-enabled again like LVM no alias. But I think now we're getting to the point where there's no sort of reported widespread breakage, and I also think we're getting better at having decent testing for incremental compilation, and I think that's also a focus of the team going forward, and the hope being that future changes aren't going to break incremental compilation without anyone realizing that that is the case.
And I think that the last year's kerfluffle that happened with people kind of like, obviously for many people, this is an important feature for their like build performance. They can't, live without it really. And so they kind of like turn it on secretly, or like, don't upgrade to a feature, compiler that hasn't been removed. So I think that as a result of that, we have gotten more eyes on the feature where, the idea is that like, as part of the Rust has, nightly beta and stable releases. The idea is that the beta release is usually like what you want to be running in production, not just because it helps you figure out whether or not I think will be breaking in the future, like in the pipeline, the new source release, but also because you can report breakage and it will help us to help us, the people, everyone with uses Rust, to figure out whether or not an emergency fix needs to be deployed to actually fix a thing that will break a ton of folks. And so the problem is that many folks were using beta, but they were using it as part of their CI. And CI doesn't exercise incremental compilation usually because you build from scratch every time. So I think that as a result of that, there's been a lot of messaging happening to get folks to say, hey, if you're developing Rust, maybe just use beta. Beta is pretty much as stable. It might break an obscure thing every week or so, maybe. But maybe not for building your release builds for your product or whatever. But if you're just developing, maybe just think about using Rust beta, the beta release channel, and it helps everyone. If you see a bug, report it, and hopefully it will head off a lot of frustration on behalf of everyone.
Yeah, I have beta as my default now on all my developer environments. for basically exactly that reason, that that's how you make sure that your workflows aren't going to break in the future, or rather that you have a path to fixing them before they break in a more permanent way.
Mhm. Yeah, and, unlike nightly, beta does not allow, any like, unstable feature flags, so you don't have to worry about, like, any, unstable features being enabled for beta. So, again, use beta, it's great.
Are we on the beta team?
I think we are.
Yeah, nice.
Team beta.
Give me a B. And
Making a beta fish, turbo fish pun.
nice.
Next up is the instant monotonicity guarantees. This is kind of a long, I wouldn't say a bug. It's been like almost like a secret feature, an Easter egg of the Rust standard library, is the fact, the idea that there's this instant type, and the idea is that if you call instant over and over again, it tells you what the time is. Kind of like gives you, like, a timestamp, and the idea is that this instant API, it guarantees as part of the API that the result that you get, it will be monotonically non-decreasing. Right? If you call this API, you will never get a number lower than any previous call of your API during that program, right?
Yep.
That's what it means to be monotonic. And when writing the standard library, it seemed like this was a reasonable thing to guarantee, because at the end of the day, Rust is relying on the OS to provide all of these APIs to actually, like, uh, give users the timestamps, and the platform APIs tend to say yes, we're monotonic, which in practice appeared to be a giant lie. There was an incredible comment in the Rust standard library, which begins with, "And here we come upon a sad state of affairs." We will link this comment because it's a great. It's a great kind of, like, sort of like resigned frustration comment in the history of Rust, and it's great to read. But now it's been removed because now we've found new ways to guarantee the monotonicity of instant. Do you want to talk about that, John?
Yeah, so to give a little bit of background here, the position we were in for instant was that the standard library promised that the return value was monotonically non-decreasing, and the operating system sometimes gives that guarantee, but not always. And so what the Rust standard library had to do was sort of put this bubble wrap around the operating system, where if you were on something that was known to be broken, it would actually use a mutex uh, to around the calls to guarantee that the value would always be non-decreasing. So basically, instant now on certain platform configurations would take a lock, check the previous return value, and if the new value it got from the operating system was lower than the previous one, it would return the previous one instead, in order to satisfy this guarantee. And this, of course, was really surprising from a user perspective, because it meant that sometimes instant was really slow because it had to take a lock, but only in certain system configurations, and it was sort of counterintuitive. Um, then there was a patch to the standard library that made instant now use atomic usize instead of mutex, which would help, but it still has this like weird flavor of we have to do a bunch of wrapping around the operating system. What's landed in 160 is a sort of reversal of that policy, where instant now will not take a lock. It will not take any kind of synchronization. It will just purely return what the operating system does. And instead, what happened is that the operations that allow you to look at the difference between two instants is saturating to zero. So that means now we could, when you call instant now, it might actually record a sort of logical timestamp that's in the past, but it's not observable to you that that happened, because you can't extract the value from an instant. You can't get like the underlying number of seconds or anything. The only way you can get at the underlying value is by comparing two different instants using, duration sins or elapsed or sub. And those methods are all now saturating to zero, which means that if you take an instant, you take another instant, and then you take the difference between them. Uh, if the operating system for some reason regressed in time, it's not going to return you a negative value. It's just going to cap that value from to be zero or higher, which effectively means that it's monotonically non-decreasing in terms of observed behavior, without incurring the cost of synchronization when you capture the time. Um, there is, of course, sort of an escape hatch here. So there's a checked duration since that allows you to notice if time went backwards. That you can use, if that is possible in your case, if you specifically want to detect this, or if you just want to guard against the case where you accidentally subtract instance in the wrong direction, which you might want elapsed, for example, to panic in that case, but it won't because it'll just clamp to zero. They do reserve, the Rust team does reserve the right here to, in the future, not clamp these to zero and instead panic if it detects that an instant went back in time, because it's not ever supposed to. And the reason they reserve this right is because panicking is sort of the right thing to do, right? Because it could be that you just got confused about which variable held the past time and which variable held the future time, and you actually subtracted them in the wrong order. And it'd be nice if you got a panic for that, saying you probably intended to swap these. And currently, that failure will sort of be silently swallowed and clamped to zero unless you use this check duration since method. But that's where we've gotten to now with 160, is that these will be saturating and there will no longer be synchronization in instant now. Did that make sense?
Made sense to me. I've got a
Amazing.
bunch of new stabilized APIs up next.
Yeah, I think there's a good list of them here. And one that I hadn't even thought about myself before was arc new cyclic. So this is a constructor for arc when you specifically want to construct a type whose constructor requires a reference to yourself. I don't think the example in the documentation for new cyclic is particularly compelling. So I was trying to come up with a better one. And the best I can think of is if you have a graph structure. So you have a struct that represents a graph, and you want every node in that graph to have a reference back to the graph so that they can look up things like, the list of edges or the list of nodes. Um, and when you create this graph, you need to create at least one node that's going to be the root node. And that root node that you create in the constructor of the graph needs to hold a reference to the graph. But to create the graph, you need to know where the graph lives. So you need a sort of reference counted thing to the graph that all the nodes can hold. But you haven't constructed the graph yet, so you can't yet create the arc. So there's sort of a chicken and egg problem. And that's where new cyclic comes in. So new cyclic takes a closure that is given a reference, a weak reference that is, to the arc that will eventually be constructed. So you can stick that weak into the nodes, into the internal parts of the data structure, and then now consider the data structure instantiated, and it will sort of do the magic that's required to turn that return an arc that is compatible with the weak that it sent to the closure. It's a little convoluted. I actually recommend you go read the source for New Cyclic. I thought that was sort of interesting in just how it needs to organize these unsafe blocks to make this operation safe. Because that unsafety now, and this is where the reason it's neat that this is stabilized, is this is an example of stabilizing a safe interface that mitigates the need for writing unsafe code in libraries that don't otherwise need any unsafety. Another stabilized API that I think is kind of neat is the escape ASCII sort of helper methods. So escape ASCII is sort of fundamentally, it takes a byte, so a U8, and it returns you a character that is an escaped representation of that byte. So that means it's sort of a safely printable version of that byte, which means if it's a valid ASCII character, it just returns that ASCII character. But if it's, say, like a tab, which is not immediately printable, it returns \t. If it is a null byte, it returns a \0. If it's some other unprintable character, it returns like the hex escape of that character. And the reason this is nice is mainly because it is a good way to print byte strings that may not be valid UTF-8, this might come up in errors, right? So let's say you're given like a byte string and you try to convert it to UTF-8, but it doesn't work. It turns out not to be valid UTF-8, but you still want your error message or your debug message to give the user some idea of what the string was so they can go correct the problem. Previously, your options weren't great, right? Your options were either to use from UTF-8 lossy, which sort of gets rid of these extra characters, or replaces them with placeholders, or you could just like print the byte like decimal values, which is often also not very great. But this new thing lets you take that byte slice and turn it into a type that implements display by printing the escaped ASCII of all the bytes, which again, it comes up fairly rarely, but when it does, this is a really nice way to be able to just print byte strings in a mostly human readable way.
One thing too we should mention about the previous, the new cyclic API is that that's also on RC, not just on Arc.
Oh yeah, that's a good point.
Also, in this release, there are some new methods on numeric types, these absdiff methods, which pretty much just give you the absolute difference between two numbers. So the idea being that you'll never get the negative, so you never have to worry about whether or not you have, like you mentioned before, in the instant example, do you have the large one or the smaller one? Well, so for example, if you have unsigned types and you don't really care about like making sure that you have a larger or a smaller or dealing with wrapping or any of that, you can just say, hey, like abs diff these types, and then it will always tell you, the max minus the min, without any worrying about overflow or any of that.
Yeah, it's one thing that's interesting here is, for signed types, absdiff makes a lot of sense to me. For unsigned types, it's a little weird because I guess the idea is for usize that it takes the larger minus the smaller.
hmm
Yeah, it's interesting because you can always subtract unsigned types in either direction. You get a value either way.
Well,
Um,
but like underflow is not defined to wrap, so.
That's true. That's true. Yeah, it's a really nice quality of life for when you need this, right? Because otherwise, what you would have to do is for signed integers is not so bad. For signed integers, you just subtract them and then call like dot abs. For unsigned integers, you would need a branch because you would need like, if a is greater than b, then a minus b, otherwise b minus a. You can't subtract them and then call dot abs on unsigned integers because it wouldn't produce the right answer. They're always absolute in a sense. They're negative, never negative in the first place. So you would
hmm
end up wrapping. So you need that branch, and so this means you could just use that same interface regardless of whether your type is signed or unsigned. I did go digging through the detailed release notes here again, and I found a couple of interesting ones. The first one is a stabilization that's not mentioned in the release notes, which is the stabilization of the panic conditional compilation. I guess, option or conditional. So the idea here being that you can write code now that is conditionally compiled depending on the panic behavior configured for this build. So you can say, struct foo or impl foo, and then some function with a pound config of panic equals unwind or panic equals abort. And that implementation block will then only be compiled if that is indeed the panic behavior that's been opted into for this build. I can imagine this being important for embedded development, for example, where you might need to configure things differently, whether abort or unwind is the intended behavior. Another one I saw is that Cargo has moved from using one TOML parsing library to a different one. So specifically, it moved from using the one called TOML RS to one called TOML Edit. And that is not that interesting in and of itself, but I thought the reasoning was a little interesting. So the reasoning was they wanted to add the cargo add command that lets you just like easily add dependencies to your crate. But cargo add has to modify the cargo toml file of your project, which means that if cargo is to do that automatically, we want it to preserve everything else in that toml file. And that includes things like white space and comments. The old toml crate would just like parse the toml file into basically, a hash map or a B tree map of strings and various toml, nested valid toml values. But that means that all of that white space information, all the common information gets lost. So if you tried to implement cargo add using the old library, the output cargo.toml would be a like stripped down and potentially reordered and reformatted version of that file, which wouldn't be okay. And so that's why this new toml library actually does a syntax preserving parsing and serialization of toml. And so Cargo's adoption of it is part of what enabled the use of cargo add. So I thought that was a neat change.
Although I will say that the idea of potentially having a cargo format just for your cargo.toml files, I have seen some gnarly toml files out there before. I might welcome that one of these days for sure, keeping everything alphabetized.
Yeah, you're not wrong. Although the old toml crate was almost certainly not that. It would format your cargo toml all right, but not in a way that I think you would be happy about.
And speaking of cargo add, that's coming in 1.62, so you'll hear about that next time.
Oh yeah, I'm pretty excited for that one too. Although actually, didn't it land in 161? Oh no, it's because I'm on beta. It's because I'm on beta. I just ran cargo add and it worked, and it's because I'm on beta.
You're so spoiled because you're part of Beta Gang.
Yeah, exactly. See, yet another reason to run beta. The last thing I wanted to call out from the release notes is a little bit silly, but it's the fact that there's a new tier 3 target that's been added, and it's MIP64 OpenWRT Linux Muscle. And specifically, so this is support for OpenWRT as a platform, which is the open wireless router technology. I don't know what the T is for, but it's basically this like open source router software firmware that you can use to like run basically Linux on your wireless router. And now you can write Rust code for those too. And I think that's neat.
I would love to see a firmware for routers written in Rust because I assume that every router everywhere is just compromised all the time. So
Oh, I'm sure. That sounds like a lot of fun to write. To write like a full Wi-Fi network stack for OpenWRT. I think that's all I have for 160.
I believe it's all I have as well.
Do we dare moving to the next number up?
It happens. The future comes whether or not you want it to.
Oh man, you're not wrong.
Inexorably, it proceeds.
All right. So the first feature of 161 is custom exit codes from main. And I need you to explain something to me here, Ben, which is I thought that I could already return different types from main. I can already return result from main before 161. So what changed?
Well, so okay. As of Rust 1.0, the idea is you just type fn main, open paren, close paren, open bracket, and that means as typical as usual in Rust, you've omitted the return type, which means that this function returns null. So the default, the zero tuple, if you want to think about it like that. And so that was how it was for a long time. And so you couldn't return anything that wasn't null from main. And the idea of improving that kind of came from the question mark operator, which is kind of like, whenever you use question mark, you want to return some result type or something, right? It can be generalized in the future too. Wink, wink. Upcoming changes. Uh, but the idea is that if main only ever returns nil, then how can it possibly be used with the question mark operator? And so the idea was, well, let's just make it so that main can return whatever we want. And so main kind of like gained like a sort of magical signature where it can like infer the return type, but it's special in that it doesn't just return nil; it returns something that implements the termination trait. And so it uses the normal returns impl termination syntax. And so because nil, I guess it might even be magical, it might just be totally normal. Where because nil implements impl termination, you can just write fn main so and so, and it just works. But the idea was that termination was not a stable trait that you could implement in your own code. So like there were it was implemented in the standard library for nil, but also for result for a few things. So nowadays, termination has now been stabilized, and so as part of termination, there is this new exit code type as well, which kind of is a generalization. It's an opaque way of referring to the idea of an exit code over in a platform independent way. And so I think, John, you were saying that Windows uses what, like I32s?
Yeah, Windows uses, I think, I32s for return types. Unix uses bits 8 through 15 of a U32.
It gets
Um,
weird, is
it
the whole
gets
point.
weird.
So the idea is that this exit code is kind of like we were talking about before last time about the instant type as being an opaque thing that you can't get the inner bits out of. This exit code is an opaque way of kind of like referring, hey, like we have this exit code thing, and if you want, you can, it implements from U8. So if you have a U8, you can like really easily get an exit code, and otherwise you can just like make it however you need to. And so in this case, now that termination has been stabilized, along with this exit code, which is part of the return type for the function, the method on termination, it means that you can now. It's a step towards. Let me think. So like, there's really two main use cases for question mark in main. One is kind of like tests, right? If you want to have like, or I'd say like, not just tests, but also like examples like doc tests, where you want the test to like look really nice. It's perfect like documentation. You can have like, a thing return, use your question mark in your documentations, and it'll just look nice and it'll just work. The other thing is kind of like using it as part of like, as a CLI. Like if you want to like, have a CLI, in general, it has, as a rule, I like to have my main function kind of read like a table of contents where it's kind of like, if you're like new to the code, come look at main and like you just see like a nice like long list of like, here's what we're doing at a high level, calling a bunch of nice functions. And if you want to keep your main nice, if you want if you don't want to have to refer to like, or have main immediately call some function which returns results that you can then use your question mark operator inside of that nice long table of contents function. It's nice to be able to say, hey, like just have main return a result type or some kind of thing that makes sense for your context. So that's kind of what we're working towards here. There are still, I think, in practice, some difficulties with using question mark in main with regard to like what does like result, how does the question mark implementation for result, the try operator for result coerce various things to like, does it use the display input versus the debug input for various things. So there's still work to be done there, but I think this is a nice step forward for that.
Yeah, and I think one of the things that they're trying to get at here, right, is that you termination or main returning impl termination has been there for I guess since Rust 1.26 or so. But the thing they're trying to get at here is the ability for you to customize what error code your process exits with. So you mentioned like command line tools, right? Where the way that termination has been implemented for result in the past and still is that if it's okay, if the result is an okay variant, then the exit code of your process is 0, which is the sort of standard way to express that something is a success on Unix at least. And if it's the error variant, then it returns 1, which is one of the 255 possible failure codes. But command line tools often want a bit more control over their exit codes because generally they want to signal what kind of failure there was so that other tools that call them don't have to like parse their output or something, but can actually look at that exit code and be like, oh, this is a 1, which means there's nothing I can do to make progress, or this was a 125, which means I should skip the current git commit, right? So there's some semantics to that exit code. And so if question mark just means oh return 1, then if you have a main function in a command line tool where all you're doing is using the question mark operator and that always returns a result which always just produces a 1, you don't get that control. And so one of the things they're trying to get at here is by giving you access to the termination trait and the exit code type, um, you can have a type that's not result, but some other type that you control that implements the termination trait and will use the appropriate exit code for what you decided to return. Now, of course, there's a little bit of a gap missing here, which is if you use your own type that's not result, then in main, so that you have control over the exit code, that means you don't get to use the question mark operator because question mark currently only works on option and result. And so the missing bridge here is the basically having a trait that represents what the question mark operator does. And this has been in the works for a long time. It's I think the current feature that's looking to land is try trait v2. And we won't go into that here because it's still on Nightly, it's still being discussed. But the basic idea is to have a trait that implements the question mark operator, or rather that the question mark operator is syntactic sugar for. and then you can implement that trait yourself. And so if you had that, you could now have your own custom result type that both implements termination in a way that gives the appropriate exit codes that you want to control, but also implements this try trait so that it works with question mark. And that sort of closes the loop so that now you can have a main that returns a type, and you get to use question mark, but you also get control over the exit code. And so that's what we're ultimately trying to get to here.
I think Try should be coming, I'm not gonna say soon, don't make any promises, but, like, it's been coming along pretty well, and I'm pretty impressed with the progress they made for it. There's a lot of, the error handling project group has a lot of, good work that they're doing. And, also, it's should note too that it's always been possible to return with whatever Xcode you want, just required calling the standard process exit function.
Right.
So
This next one is, we've been talking about constification for a long time. And this is another instance of that. So specifically, we're seeing here more capabilities for const defense, and this includes both the bodies of const defense, but also the signatures of those functions. Do you want to talk a little bit about this, Ben?
Sure. So once again, constfn just lets you run various code at compile time. Kind of like normally, if you have a const value, say const foo equals const foo colon like I32 equals 4, right? Then you kind of think of it as kind of like being whenever you refer to foo anywhere else, it kind of copy pastes that value. There's not really any kind of like thing beyond that. It's sort of like a single static value, and you can think of any like evaluated const like this as kind of the same way, where like the idea is Rust wants to evaluate this whole thing once and then like coalesce everything down into a value and then just copy and paste this value throughout the entire program. So even though it does involve like running code at compile time, it doesn't need to be that slow. It's a little bit slow in practice if you do certain things. Obviously, you can make anyone can make any code run slowly. So it does require some use to be some care to be taken. But overall, it's a great thing to give users the option to make more things const. And so also to give the standard library the option to make more things const, because as you can imagine, if a user wants to do something in their own const code, but standard library doesn't offer the feature, if they want to call some function that isn't stood and it's not const, well, they're out of luck. And so the idea is you want to support as much of stood being const as possible, which means supporting lots of features that are used commonly in Rust code. And so const has been kind of like, because of this property of wanting to remain kind of a pretty simple, sort of like the copy and paste model of evaluation. It's been proceeding very carefully to make sure that there's no real you can't do things that would. I'm not sure if like it's really a long term goal to make sure that this is the case. I think it might be extremely difficult to ensure, but I think it is at least a short term goal. And so what is stabilized this time is that you can now pretty much the most important thing is the ability to cast pointers in a constfn, the ability to have a constfn with trait bounds, and so like you have the usual fn foo bracket ankle bracket t colon whatever copy etc. So you can have like generic const fns, the ability to use din traits, so trait objects, which is pretty neat, I think, because we think of din traits as being a very dynamic thing, and so the fact that it can handle that is a neat sort of thing, and also infiltrate, and so infiltrate too, not just the arguments, but also the return values for infiltrate now work for const fns, and so basically the idea is you now have generic const fns.
Yeah, to me, this feels almost like making writing const defense feel more like writing regular Rust.
Which is the end goal, is that kind
Right.
of like it should support whatever is possible to support while keeping the goals of constfn in shape and not exclude anything that doesn't need to be excluded. And so const is just hard to implement soundly and safely in a type safe way, right? If you like imagine if you it's easy to for example, if you if you had a function that like took said, hey, give me a an array of length, and then at the length is like some constant function, and you allow like say like random numbers like an RNG to run, you could like totally break type safety that way, but both calling that function and defining it even. So you want to be careful about what you allow in constfn to make sure that Rust meets its safety goals, since it's very tied in with the idea of thing of the type system, not just values, but also kind of like I don't want to call it dependent types. It's not quite the same as like const generics, but it's up there. It's definitely interrelated.
Yeah, I want to. I'll link in the show notes too. There's a tracking issue for all of the different constfn evaluation abilities that they want to land in the standard library and in the compiler, and it's a pretty cool list. And I think they're like about halfway. Although whether that means half the effort is a little unclear. But it's a cool issue to take a read through of all the things that might actually become possible in constfns. Like, I think one of them you pointed out was the support. One of the things they're planning to support is asynchronous blocks in constfn.
It's listed there in the document. I can't. I mean, I have a hard time imagining why you would ever want to need to use an async block inside of a const fn. Why you would need having such a stringent IO requirements that you'd need to like invoke an executor to handle your IO while you're compiling
Yeah,
something.
it's
But I
quite
mean, like
something.
like I was saying before, like you don't want to exclude anything. It's not. I don't think it's a high priority to support this, but if it can
Who
be
are we
supported
to
nicely,
say whether it's
who
reasonable?
are we? Right? Like who are we? Like you're the user. So
Exactly.
we can't predict what you might want to do. And
Are
I
you
think,
saying the customer is always right?
the customer is often right, at least.
I see.
If you're a Rust user, then yes, you're always right.
That
So,
is true.
mhm.
And Rust
um,
users also luckily always agree on everything.
yeah,
So
of course,
therefore it's easy to apply that rule.
great minds think alike.
That's right.
I think also sometime in the future, the idea is, I think is still some feature gap with so C++ also has a kind of a const expr feature, which is similar to this. And I think some things that supports, which is a neat thing, which is it lets you do allocations at compile time, as long as those allocations don't like escape. Because you can imagine, if at compile time you have a pointer to something in the heap, but the heap doesn't exist whenever you ship the program to somebody, unless you want to do like really wacky like static memory shenanigans, which might be possible. But I think in the meantime, like it should be fine just to allow users to say calculate something with if you just want to do a vec collect, like an iter collect into a vec at compile time. That should be fine, right? So
What I really want is I want eval at const time.
you want eval at all? I mean, well, it isn't const is I guess just eval. It's using a Rust interpreter.
Yeah, but I want the ability to pass in strings, though, Ben.
Well,
I
so you do
want
have.
to. I want the good old days of taking a string from the user and evaling it.
Well, first of all, you can just say, spin up a Python interpreter from your Rust program and then eval some Python real quick. But also, the Rust, the interpreter used for constfn is also just a Rust program. It's a Rust crate. I'm sure you can just grab it in, pull it in as a dependency, and compile whatever you want. And also, at the same time, you can just shell out to the Rust compiler,
Yeah, I
right?
was
As
gonna
part of
say,
your
actually,
your
thinking
program.
thinking about it some more, I guess eval at const time is just calling rust C. Like that's what that means.
Yeah. So, which I think is how some languages even do it.
Oh
So.
yeah, I believe that.
It's so much easier than what Rust does, which is like trying to be very type safe.
This next one is a quality of life improvement that I'm really happy to see. I've certainly hit this error before too, and been like, "Ah, that seems unnecessary." The observation here is that we have these three standard IO streams: standard in, standard out, and standard error, and each of them is like a global static in the standard IO module. And each of them have a lock method that you can call in order to get like exclusive control over that stream for the duration that you hold the lock. And that works fine, right? So you can, take a lock of standard in, and then you can keep reading for it without further synchronization, and you know that no other threads are reading from standard in at the same time. The downside is that the lock method takes a reference to self, and so this means that like when you call standard IO standard in, what you get back from that is a value on your stack that refers to that static standard stream. Um, but when you lock it, the lifetime of the guard you get back is tied to that stack value, not to the global static that represents the standard in stream, and that's just unnecessary. It's an unnecessary limitation because realistically, even though you drop that stack value, it's not as though standard in goes away. Um, and so what changed with 161 was that the lock method will now return a guard that is uh, that lives in the static lifetime rather than being tied to the local stack variable you have representing standard in, because standard in always stays around forever. And this means that now, when you call standard IO standard out to get the standard out stack object, and then call lock, you can then drop that, or if it gets assigned to a temporary and then you call lock, you can still keep using the guard and everything is fine. So it just makes that API a little more ergonomic, but still in a safe way. We have stabilized APIs for this release as well, and there was one here in particular that I've been watching for a while, which is the addition of a retain mute method on vec and on vecdec or vecdq. I think we've had this discussion before. I don't know how it's pronounced. Um, but for retain mute, this is exactly the same method as retain. And so if you're not familiar with it, the retain method on vec um, lets you pass in a closure, and any element for which the closure returns false is going to be returned from the vec. So the idea being, you're going to call retain on this vector, and basically you're going to keep only some of the elements. And the reason why this is a dedicated method is because it turns out that if you remove a bunch of elements, you can be more efficient about how you remove them from the vector than if you removed each one individually, right? Because if you remove an individual element from a vector, you have to shift all the elements over to cover the gap of the element you just removed. But if you remove many things from a vector, you can shift them in batches, and that turns out to be more efficient. But when retain was originally written, it was written with a signature where that closure only gets a shared reference to each element that's being walked over. And th- that's sort of artificial because the retain method requires a mutable reference to the vector, and it walks over the elements one at a time. And so it knows that it has an exclusive reference to each element. It just doesn't give that exclusive reference to the closure. It just gives a shared reference. And that limitation, usually doesn't matter. Usually when you call retain, all you care about is, you want to check some property of the element, and if it's true, then you want to remove it, and if it's false, you want to not remove it, or vice versa. But sometimes while looping through all the elements using retain, you also want to modify the elements, maybe to like cache the fact that this element should be kept in the element itself, or updating some timestamp in there or something. But retain wouldn't let you do that. And originally the thinking was, oh, we can just fix this by making that closure be given a mutable reference instead. But that's backwards incompatible because you're changing the signature of this vec method. And so instead, we now get vec retain mute, which is exactly the same as retain, except that the closure is given an exclusive reference, a mutable reference. And in fact, now vec retain is defined in terms of retain mute by just calling retain mute with a closure that turns the exclusive reference it gets into a shared reference and does nothing else. But it's sort of a journey to why we ended up here. And at this point, arguably we could deprecate retain, although there's no reason to avoid retain. It works just fine. So I don't know that it's going to be deprecated, but it's just worth knowing that now there is a retain mute that is strictly more powerful.
Unless you have any other stabilized APIs, we can move on to the constification. And so, as mentioned previously, the idea is that if you are a user writing const code and you want to use standard library, which, as a user of Rust, you probably often do, you want to make sure that any APIs you use are compatible with const. And so, it's an ongoing process to forever find things that can be made const, especially with all the fancy new features of const as they gain them, and then make them const. And so, we've got a bunch of scary methods on pointers, and then some stuff with slices being convertible to pointers. So,
Yeah, I thought
uh,
one thing that was interesting about the const list here is that all the operations are, pointer operations. And you might think sort of intuitively that why would const code ever deal with pointers? Because in const, you don't have like the heap. You don't have allocated memory in the same sense. So what are pointers useful for? You can't return them anyway because what you evaluate at const time, that memory isn't there anymore at runtime. But again, this ties back to, you might construct a data structure for the purposes of computing the thing that is ultimately just a const value. And those data structures might want to use pointers entirely at compile time. And so therefore, you need these pointer based features even in const evaluation. Here too, I did my usual deep dive in the changelog, and I thought there were a couple of things that came up that were interesting. One is that the available parallelism method, which we've mentioned, I think in 159 and 158, gained support for parsing out Linux C group quotas. The idea here being that basically available parallelism got a little bit smarter. It used to be fairly naive, where it would just tell you basically the number of cores on the machine. But now it will also take into account if the operating system, or in this particular case, Linux, has limited which cores that process is allowed to use, or how much CPU resources that process is allowed to use when computing available parallelism, so that it doesn't return 16 if you're only allowed to use 3 cores. And this also has led to the adoption of available parallelism being used by Cargo instead of the num CPU scrape, which mainly just removes one dependency from Cargo itself and thus speeds up its compile time. But it also might mean that you could now see Cargo using more or fewer cores than it used to, because it now uses a different mechanism for determining how many cores it should be using to build in the first place. Another change that I'm really excited about, although it is nightly only for now, is that Cargo gained support for sparse HTTP registries. So the idea here being that when you run Cargo commands, and especially Cargo update, you might have seen that it does like a clone of the Git index that represents the registry of all the crates on crates.io, and that can take a really long time, especially if you haven't run Cargo update in a while. And this work has been ongoing for years now, actually, of supporting an alternate registry format that is based on HTTP instead of being based on Git. And where we've landed now, and we'll link the relevant RFCs and PRs in the show notes, but is a nightly implementation of that and support for that in crates.io API itself, where now Cargo will only, if you use this sort of experimental registry implementation, it will only fetch the bits from the index that it actually needs in order to build a given crate, rather than downloading like the entirety of the index. So let's say that you have 100 dependencies or something, it will only download the index entries for those 100 crates, rather than trying to download everything. And so this should speed up updates by a lot, and certainly things like CI builds by an enormous amount, because
Yeah.
in CI settings you never have a cache, so you always have to clone the entire Git registry, and that's no longer necessary.
More forward-looking stuff is that in a future release, the Rust developers, the compiler developers, intend to increase the baseline requirements for Linux and glibc. So the idea is here is that so the Rust edited library itself uses various features, like I mentioned before, kind of like the instant stuff, right? To uses various APIs provided by the OS to perform certain tasks. And so over time, if it wants to do newer things, it needs to upgrade its versions of glibc or its assumed version of Linux. And so more normally this happens. It's a very slow process because Rust wants to support a very broad range of platforms and not arbitrarily limit itself. If it could support a thing, it wants to support a thing. The problem is that LLVM also supports these platforms, and gradually Rust needs to move forward with LLVM, and so LLVM slowly deprecates support for older platforms. And so in this case, there is a change proposed, not yet merged, but proposed to increase the baseline requirements for Linux to kernel version 3.2 and glibc to version 2.17. Now you may ask, how old are those? Linux kernel 3.2 came out in early 2012. glibc 2.17 came out in late 2012. So both of these long predate Rust's own 1.0 release. The complication in this fact, or in this case, is that the last version of Red Hat Enterprise Linux to support the current kernel and glibc support versions is version 6, which came out in 2011. The newer release, Red Hat version 7, came out in 2014. So if we did this, we would need to bump, anyone using Red Hat version 6 would need to upgrade to Red Hat version 7, which apparently is a lot of people are still on Red Hat Enterprise Linux version 6, which, came out in 2011. Which, enterprise stuff, it moves slowly. That's totally fine. And so if you are a kind of person who needs your Rust code to compile on Red Hat 6 and you can't upgrade to Red Hat 7, which again also came out well before Rust's own 1.0 release, then there is a link to the discussion where your feedback can be left, and eventually, at some point, Rust's hand will be forced in terms of upgrading various things. But there might be certain mitigations they can do with trying to avoid using certain features of certain platforms in certain ways. So we'll leave the link in the show notes.
Part of the challenge here is also, things like embedded platforms where people might use Rust to target, let's say set top boxes or like cheap consumer wireless devices that are running just like old versions of Linux. They have no update story, and they just will never be updated, and so their hand is sort of forced that they can't, they don't have the ability to upgrade those boxes in any meaningful way. And it's sort of unfortunate that we end up getting pushed this way. Although at the same time, as you say, like Rust's own hand might be forced, but also not upgrading comes with a huge cost too for all of those who are able to run newer systems. With
Hmm.
when you increase the baseline version, you can do things like make use of better operating system APIs or more efficient operating system APIs, more correct ones. For things like we had the discussion of instant earlier, those bugs in the monotonic implementation of instant are generally only on older platforms, and so you might even be able to say start panicking in the instant comparison methods when you drop older versions of Linux where we know that that bug exists. So there are incentives for upgrading beyond just we have to. There are attractive versions of using newer versions of glibc, newer versions of the kernel as well. So I think the way the discussion is currently going is that this change is probably going to land in 164, so which is being released on September 22nd. At least that's where the libs team has landed so far.
And the worst case scenario, too, you mentioned these older platforms, is that maybe you might just not be able to upgrade your Rust compiler beyond a certain toolchain version, which, compared to whatever ancient GCC you're probably using on that already, it probably isn't that big of a deal.
Right, exactly. There's another compatibility note that I want to touch on briefly because it hit me. So this is the way that Rust C passed linker flags to the underlying linker that it uses to link your final binary or other binary artifact has changed slightly, and this means that if you have build scripts that emit additional linker attributes, or if you have other configuration things that add link flags to cargo or transitively to Rust C, you might now see your build start to fail if those link flags are not ordered correctly. Um, that is because your old ordering was incorrect, right? So linkers have very particular opinions on the order in which link flags need to come, and Rust used to sort of treat them a little fast and loose and place them not quite randomly, but not necessarily in the order they were passed in. And now they are being passed in a specific order, which means that if your linker flags only worked because Rust C passed them in a weird order to the underlying linker, that might change. And so you might get errors around linking that are going to be related to the particular order in which you emit linker flags, and you might need to go correct that if you start seeing that coming up. I think I have two more sort of minor things here. One is a little qualitative improvement for ignored tests, where starting with Rust 161, you can now provide a message when you ignore a test. So with Rust unit tests, you can use the pound square bracket ignore syntax to say that a test was ignored or should be ignored when run with cargo test. And now you can say, pound square bracket ignore equals and then put a string. And when cargo test doesn't run that test, it will say ignored, and it will also say the reason that you put there for why that test was ignored. So it just makes the cargo test output a little more helpful to humans. And then the other one is the sad removal, or I don't know if sad is the right word, but it makes me emotional. Is the
Does your
removal.
soundboard have taps?
That's right. It's the removal of the everybody loops pass. Do you want to say a little bit about everybody loops, Ben?
I think this pass dates back to it was an unstable compiler flag, I believe. It was never stabilized as far as I know, which was just mostly useful for debugging and reproducing, minimizing various test cases, which just sped up your compiler by taking all the bodies of all your functions and replacing them with an infinite loop. And an infinite loop, in case you're not aware, is an example of a diverging statement because like it can never return. It's kind of the same as a process exit or a panic, where like once you call this function, it's never going to return. And so one of the properties of diverging functions is that they satisfy any type that you can imagine. And so if you replace the body of every function with an infinite loop, it will always type check. Surprising result, but it's true. And so it was just an ancient sort of flag. And because it replaces every body with a loop, it was called everybody loops. And it was a favorite, fun artifact of ours from the ancient history of Rust. And so sad to see it go, but really nobody uses it these days.
Yeah, I think it actually was used for a period by RustDoc. The idea being that, RustDoc doesn't actually care what the body of any of your functions are because it's just generating documentation. So why should it need to do all this complicated type checking of function bodies? So let's just use everybody loops there too and make RustDoc compilation of your crate faster. And then I think it got removed again because if I remember correctly, there's like a weird interaction between divergent types and impl trait in return position. Because if you have a loop, so there is no return type because you will never return, but your function returns impl trait, which is supposed to be a sort of existential statement of there is some type here, I'm just not going to tell you which one it is, then Rust gets really confused because there is no type to put there because loop doesn't return a type in the traditional sense. And so there's no type to assign to that impl trait.
So what you're saying is that if we stabilize the never type, we can bring this pass back.
Well, so I think it was partially that and partially for like async functions or async blocks or something where because they implicitly use generators, there was like another existential, there was like something real weird here.
Well, those return infiltrate as well, so.
Yeah, that's true. So ultimately, it was adopted by RustDoc for a while, and they got removed from RustDoc. And at this point, as Ben says, it's more of a historical artifact than anything that actually gets used a lot. But we will miss it greatly, mostly because of its name.
John, in lieu of taps, can you please play the drum fill?
Yes, of course. I will play a sad drum
A
fill.
mournful drum fill.
I did as best as I could.
All right. And is that it for 1.62?
161, you mean? 162 is going to
That's
come out
right.
soon,
Oh,
though.
I'm already living in the
Don't
future.
get ahead of ourselves.
We are recording this quite late in the life cycle of 1.62. So
I don't know what you're talking
2
about.
weeks
We,
away.
we recorded this the day 161 dropped, and
Listen,
it's just
listeners,
our lazy listeners who haven't listened to it until now.
unlike John, I'll never lie to you. And so
Wow.
peer behind the curtain here.
That's right. I mean, I also never lie.
It's true. You just told me. So
Exactly. There's one last thing I want to touch on, just sort of on the exit here, which is there was a post to the Inside Rust blog on the Rustlang roadmap for 2024. We're not going to go through the whole roadmap here. That's sort of its own little discussion. And the roadmap itself is more of a living document. So this was almost like a snapshot of that living roadmap. But at a very high level, I wanted to just sort of tell people that it exists, that you should go look at it. The headline of the document is scaling empowerment. And the sort of three things that the Rust team wants to focus on for Rust sort of going towards 2024 is flattening the learning curve, helping Rust users help each other, and helping the Rust project itself scale. So if you're intrigued by any of those or wonder what any of them mean, I highly recommend you go check out the roadmap. We'll link it in the show notes, and you can catch up and give your opinions and see how this might or might not affect you.
And to emphasize too how the roadmap works, it's not really a set of goals so much as it is kind of like current priorities and like what people would like to achieve. When Rust project sets roadmaps, it's more like what are folks working on right now, and what do people like expect they'll have finished by this time.
Yeah, it's like what are we currently prioritizing and focusing on?
Yeah, it's Rust is kind of an anarchic bottom up organization. There's no boss to fire someone for saying, hey, you didn't finish the empowerment stuff. You're fired.
Wait, you've lied to me, Ben. I thought you were the boss of Rust.
Well, I did say I'd never lie to you, and that was in fact a lie.
And I thought Steve was the CEO of Rust.
Steve is at best the CFO of Rust.
I see.
I don't know what that even means. That joke went nowhere.
That's true.
I don't know anything about corporate structures.
Wait, was that right? Did I do that
Yes,
right?
that's totally right. You did it. You did it.
All right. I think that's all we have, Ben.
That's all we have. Yeah. So, shall we depart once
Yeah,
again?
we'll go fade back into the bushes like Homer Simpson
Mhm.
and rust into our chairs until
But for
next
next
time.
time, we need to rehearse like a musical number, like us like so long, farewell,
Auf
auf Wiedersehen,
Wiedersehen,
goodbye.
goodbye. I
We'll work on that.
wish you all. Oh wait, we were stopping. Oh, okay.
Oh, no, that's for next time. Like I said, next time. That's the
I see.
taste. You can't. Got to make them come back somehow. Why
That's
else would
true.
they ever come back to us?
That's true. It's got to come back to haunt us sometime.
Got to be a tease.
Yeah, exactly. We got to leave the listeners wishing for the rest
Leave
of
them
the
wanting
song.
more.
That's right.
Always hungry.
All right. Bye, everyone. Bye, Ben.
See ya.